Well, hey, um, hello. Welcome to what is known as another video. It's great seeing you here. Welcome. This is our very first lesson in our new unit dealing with products of decimals. So again, thinking about that concept of multiplication products, right? Product being the answer to a multiplication problem with decimals. We have dabbled, meaning we have played around with this a little bit. And one of the things we've learned recently is that like just our number sense and estimation has been a really helpful thing. But today we're going to really start to dive in with understanding the concept of multiplying with decimals, and we're going to do so around that base 10. So as we kind of like unwrap this today, be patient because there's a lot of stopping and thinking with this one in this video that really helps you kind of put things together. So again, as we break things apart, when we talk about that base 10, we're talking about the general concept of our numbers, right? Base 10 is the concept that 10 of one thing make another. It is also how we count. It is our counting system. And it also really just comes down to place values and values, right? And values. I'll use that as a different color. And what I mean by that, again, is understanding that concept of knowing that when we have place values, let's see, I'll just do a quick place value chart. And we have something like the ones place, and we have the tens place, we have the hundreds place, we have the thousands place. You see where I'm going with this. And then we have the 10,000s, I guess. It's getting a little sloppy, but we have those things, right? Understanding that that place value, that is the concept of base 10, knowing that if I have a 1 and then I get 10 of those ones, I get 10 times bigger, I end up with 10, right? And if I have a 10 and then I get 10 times bigger, I end up with 100. And that's what base, oh, look, it's like a smiley face. That's what base 10 is all about, is that concept of getting 10 times bigger in every place value. And then that also makes sense when we think about its value, right? Something in the tens place is 10 times whatever that digit is. So if I had the number 431, well, this is 3, but there's 10 of them. So it's 10 times bigger. So it gets me to 30. And this is what we talked about in the past in terms of base 10 and place value. So as we break that down again, going into that next step of like base 10 multiplication, something we've done before, that's us talking about a concept like something like 300 times 700. Well, we can do that concept of quick math thinking, oh, well, if I think of my non-zeros, if I think of just 7 times 3, I know that gets me 21. But it's not just 7 times 3, right? It is actually 300 and 700. So that's the base 10 part, that this is ones, tens, and hundreds. So this is 100 times greater, or again, 1, 2 place values. So I need 2 zeros here. And this is 100 times greater. So I need 2 more zeros. And we can do base 10 multiplication in that concept of understanding place value. So 300 times 700 is 210,000. But really, the concept in helping us with multiplication is just knowing those single digits. So that's base 10. And that's a quick review. Like I said, I don't know, I say quick, but this video has a lot to it today. We're going to be thinking about that when we get into the realm of multiplying decimals and what does that mean. So let's get into it. Let's just go for it. And use a couple examples, right? So I'm going to break it apart kind of bit by bit. Let's start with a decimal, right? If we have 3 and 63 hundredths, right? And that would be a decimal. We have 3 wholes and we have 6 tenths and we have 3 hundredths. So 3 and 63 hundredths. Well, let's first start with a couple of things that we already know with multiplication. One, well, if we multiplied this by 1, the greatest thing about this is that the identity rule of multiplication states that if I multiply any number by 1, I still get that number. So 3 and 63 hundredths times 1 is 3 and 63 hundredths. And that's always a really good way to start thinking about math and thinking about this multiplication with decimals, is remembering that this rule that makes life feel easier does apply to decimals as well. And we could do it with anything, right? If I had 107 and 43 hundredths and I multiplied that by 1, guess what? I get 107 and 43 hundredths. So it's, that again, that identity property of multiplication is really helpful. And this comes in handy because 1 is the same thing as the ones place. So it's part of that base 10. Base 10. So let's take that to the next stage. Let's say we take that same decimal, 3 and 63 hundredths, and we multiply that by 10. So let's think about what that means right away. We're getting 10 times bigger. So here is that case that we know in multiplication, things get larger. We could also use what we already know from before in thinking about this idea that the identity property of multiplication states that anything times 10 is, or sorry, anything times 1 is that same number. So once again, I could have this if I was multiplying by 1, but I'm not. I'm multiplying it by 10. So I actually have to get 10 times bigger. So let's think about that. Let's think about the concept that if I had 3 that needed to get 10 times bigger, wouldn't that become a 30, right? If my 3 got times 10, my 3 wholes times 10, that's going to get me to 30. So then we start to think, oh, well, actually, that decimal, oh, wow. Did you see that? That was wild. Let's see if we can undo that. You see all those numbers that disappeared right there? That was weird. That decimal, let's see if we can do this again with, okay, that decimal we put in there, it doesn't belong right there. In fact, the reality is that when I take 3 and 63 hundredths and I multiply it by 10, I end up with 36 and 3/10. And what's cool about this base 10, when we start with base 10 with decimals, we can see already we're not changing our digits. Notice that this is a 3, this is a 6, this is a 3. And in my answer, I have a 3 and a 6 and a 3. My digits don't change. Their location does. And that's even something we talked about. Whoa, where is that? Back here, where again, when we use base 10, or we could even say here, the location of those digits change, right? Here we just had a 21, but it ended up being in the 100,000s and 10,000s place because of how many times greater it got, right? Got 10,000 times greater. So same thing here, as you noticed, 3 and 63 hundredths times 10 is going to get me actually 36 and 3/10. And so if we continue that trend again, and we say, okay, well, what if I had 3 and 63 hundredths and I multiplied it by 100? Well, again, let's take that concept into account and say, okay, well, I have 1 times 3 and 63 hundredths is 3 and 63 hundredths, but it's not 1, it's 100, right? So I'm actually getting 100 times bigger. So if we thought about that 100 times bigger times that whole number, because that's something we know, 100 times 3, well, that's going to give me 300. So if we actually look at our answer, we could start to think about, oh, this decimal doesn't belong here. It belongs somewhere where I'd have 300. And you can see that would actually, oh, no, oops. You can't see that because I erased that. I meant to draw. You can see that would actually put our decimal right here, which would make 363. And in this case, we could just say 0/10 because there's nothing there. We could put the 0 in there, but that's still a decimal, right? And you can already see how, again, the digits do not change. It's just the location of those digits. They're getting larger, right? I got 100 times bigger. And that goes back to that MBT.1 that I was having us work so much on of like, what's the relationship between the digit 3 in the tens place and the digit 3 in the tens place? Well, it's 100 times bigger, right? And you see that happen. This 3 here is shifting. Everything's shifting a place value. And so when we multiply by 100, we get 363 and right. And then, so let's take that even deeper. Let's say now with base 10 multiplication, we're continuing in that trend. We have 3 and 63 hundredths, but this time we're going to multiply it by 1,000. Okay, well, again, knowing what we know, I should use some equal sign here. Knowing what we know again about that base 10 multiplication, well, I know that 1 times 3 and 63 hundredths is 3 and 63 hundredths. But now, look at what's happening. We're getting 1, 2, 3 place values larger. So actually all of my numbers need to shift up another place value. And I'm going to try to model that on the next page so we can look at it this other way. But if we think about that, that would actually mean that we're thinking about this 1,000 times 3. That would actually get me 3,000. So that means my 3 now has to be in the thousands place, which puts my 6 in the hundreds place, which puts my 3 in the tens place. And now, notice we have nothing in the ones place, but we did put a 0 over here. So in a sense, that would be shifting over from the previous number. And it does go here. And I have a decimal here. And that's what I would get. If I have 3 and 6300ths and I multiply that by 1,000, I'm going to end up with 3,630, which is a cool thing to think about. Like, imagine if you had $3.63 and someone said, oh, I'm going to give you 1,000 times more. You'd end up with over $3,000. So this is that base 10 concept with decimals, is that think about when using base 10, remember, it's always going to be 1 times what you have. So those digits don't change. Right? But then when you multiply it by something like a 10 or 100, it's all about place value. It's all about shifting. And so let me try to kind of model that again on another page here. I'm going to go back to, I'm going to use this. So I'm actually going to try to draw up some sort of place value chart. And let's see here. I think we said 6,300. So I guess we'd need the hundreds. So hundreds. Uh-oh, this is going to be hard to write. And this is tenths. I'll do that in another color just to remember decimals, right? And then we would have the decimal here. And then, oops, we would have our ones place. Whoa, what's going on? Whoa, what? Oh, I'm getting laggy. We'd have our ones place. And then our tens place. And then our hundreds place. Grids. And actually, I'm going to change colors again because I'm changing periods, right? That's one period. Here's the thousands period. So we'd have 1,000. And we'd then have 10,000. Sorry, I know my handwriting does not really show. Oh my gosh, we're having some issues here. That says 10,000. And this would be like 100,000. Sorry, that's a number. I know it shouldn't be. It should be a word. It's place value. I don't know, the pen's not really working. Anyway, so there would be like all of our whole numbers down here. And then the blue would be our decimals. So if we go back and think about that process where we went, we said we had this number 3 and 6,300s, right? So that first time, let me go back to that. That first time, in this case, when we multiplied it by 10, right, everything got 10 times bigger, right? All of our digits over here moved. We got to the 30s. And we could see that again here, where if we multiplied by 10, well, that 10, I'm going to say 10 times 10 over here, that's 1 place value, right? So everything, I'm actually going to draw a line here. Everything would shift up 1 place value. So this would go to the tens place. This would go to the ones place. Decimal stays, and this would go to the tenths place. So that's what we have in that case. What's up?
Just checking in to see if you all felt like you had what you needed for the social justice curriculum.
Yeah.
Awesome.
Absolutely.
Great. Yeah. All right.
Thanks.
Well, take care. We'll talk to you soon.
Cool.
See ya.
Okay, sorry, there was a pause in there. That was a fun moment. That was real life. We were recording, and then Miss Baumgarten came in and said hello. So maybe you heard her in the background. Moving on. Okay, so back to multiplication. So where were we? So as you can see, again, notice how everything's shifting, right? Everything shifts up a place value when we think about where those digits stay the same, but they go to different places, right? And let's go back and then look at this other one. I'm gonna go backwards here. I'm gonna kind of delete this stuff. And let's say in this case, we multiply by 100, right? Well, that means I'm moving 2 place values. So that would mean that this 3, right, would first go to 1 place value here, and then it would go to the other here. And then the 6, it would move here, and then it would move here. I guess I could write the 3 instead of arrows. And this 3 would shift up here and shift up here And again, my decimal stays right there. So therefore I would need a 0 here. And that is what had happened when we took, gosh, sorry, this is looking messy. When we took 3 and 6300ths and we multiplied it by 100, we ended up with 363. And that also makes sense because we're multiplying. So numbers definitely get bigger. So as we come back here, that's what we saw here. Okay. So that was like a super long intro. We haven't even really done the math. And maybe as you do this, you'll start to see some patterns, and let's play with that. Right. So now let's kind of go with that concept again. Sorry, that was so much. And an interruption. Well, I shouldn't say an interruption. And we were visited by a guest speaker in the background as another teacher came into the room today while we were filming. So let's get into that. So let's say we have 42 and 3/10. And today we start off, let's say we have to multiply it by 1. Okay, well, that makes sense. Nothing changes, 42 and 3/10, because 1 times anything is the same thing. But then as we get to 42 and 3/10, let's say someone comes along. I don't know why there's always someone coming along and asking you to do math, but that's my favorite scenario. And says, oh, well, what if we did base 10? We said we had 42 and 3/10, and I want you to multiply that by 10 to the power of 4, right? So again, no, remembering that this is still base 10, these powers. Well, what we do know is this 4, this exponent of 4 tells us we have 4 place values, which means this is getting 4 times bigger, 4 place values bigger, if you will. So we could think about that on the chart. We could also think about that in how everything moves up. And they would actually move up 4 place values. So I'm going to actually start with just the 4. Like right now, right, the 4 is in the tens place. And so if I had to move 4 places, 1, it would move to the hundreds. 2, it would move to the thousands. 3, it would move to the 10,000s. Right? So there's 1, 2, 3, 4. Now it's got to jump, and it's actually going to jump all the way to the 100,000s. So what that tells me is, for starters, this 4 is now going to end up in the 100,000s place. I should have made this so messy here. That was supposed to be oh, oops. Shoo. I almost deleted the entire screen. So if that moves to the 100,000s place, I could think about that. I'm going to take, and I'm going to put, nope. Which one? This one. I'm going to put this 4 in the 100,000s place, which means the 2 is going to be in the 10,000s place, and this 3 is going to be in the thousands place. And then that actually means the hundreds, tens, and ones end up right here with zeros, meaning that when I have 42 and 3/10 times 10 to the power 4, I end up with 423,000. Oh, okay. I feel like I'm actually overcomplicating this. So let's see. What else could we do with that? Let's apply it this way. We're going to look at one more, and then, yeah, you're going to have to try this out. So don't be afraid to ask questions, because I don't want this video to be too long. So let's go to this again. I'm going to go to a little trend here and see if we can't notice a trend. Let's take 1 and 4600ths. Okay, so I'm gonna write this multiple times in a row, because I'm gonna see if you can't also see a pattern. What I've talked about for the past 15 minutes is why it happens, but here's a how. Like, here's, like, sometimes we just need a how. Here's a little shortcut. Let's see, we're gonna multiply this by 1, we're gonna multiply this by 10, we're gonna multiply this by 100. Sorry, there's like things in my screen I know you can't see. It's gonna drive me crazy. I don't like this update. And then 10,000. Okay, so yeah, so if we answered that, I'm gonna write down the answers just so you can start to kind of look at a trend here. So this, obviously, 1 and 4200ths. Next, we end up with 14 and 6/10. Next, we're going to end up with 146. Next, we're going to end up with 1,460. And next, I'll just maybe put the decimals in there anyway. And next we would have 14,600. Okay. So that's what the answers would be. And actually what I want you to do is pause this video and just look, do you see a pattern? Because math is a pattern. They're patterns. They're puzzles. Math is a bunch of puzzles and patterns. So you're often just trying to find what that pattern is or that puzzle is, because math is very constant, right? The rules are kind of constant. They don't change. So pause this and kind of look to see, are you noticing a pattern? And I'm now talking because you unpaused it and you looked for a pattern. Let's see if you found a pattern. And if you never paused this and didn't look for a pattern, shame, shame, shame. I'm coming for you. Hopefully you really did pause it and look for a pattern. But let's play around and let's kind of look at what happens. So if we look in here, and here's the pattern we can look for. In this case, nothing changes, right? We multiplied it by 1. It's the same thing. Now, in this case, I have 1, 0. And if you look where the decimal is now to where it was, you can see the decimal actually moved over to the right 1 place value. Right? You see how that was? It was between the ones place and the tens place, and now it's between well, it still is between the 1 and the tens place. It always will be. What am I talking about? You had a 1 in the ones place, but now that 1 is in the tens place, right? It moved over. And same thing here. If we look, right? 1, 2. Well, 1, 2. The decimal then would come at the end of the 6, and that happens right here. Okay. Okay. Again, counting zeros. I see there's 3 place values because it's 1,000 times bigger. Well, that would mean this decimal would move 1, 2, and a third place, which again, this would be an empty place value that we could fill with a 0. And that's what you see over here. And so then again, 1, 2, 3, 4. Well, 1, 2, another place value, 3, another place value, 4. And that would be, again, what we see, 1, 4, 6, 0, 0, then the decimal. So there is like this whole concept of understanding, oh yeah, my 1, right? Like in this case, my 1 is going to end up in the hundreds place. My 1 whole is going to end up in the thousands place, which it does, you know, and my 1 whole ends up in the 10,000s place, which it does, right? That would be one understanding. And then the other one is what we're seeing here is that we could literally say, oh, well, if I'm multiplying by 10, I'm actually going to move that decimal over 1 place. If we're multiplying by 100, I'm going to move that decimal over 2 places because, again, it's all a thing about place value. Okay, I said this would be it, but I lied, so never mind. We're going to look at this one more time, thinking about both those concepts. So here's 5, and I promise, here's the last one. So 5 and 200s, and if we multiply this by 100, let's play with a couple of concepts we know. 1, I know that 5 and 200s times 1 is 5 and 200s. I also know that it's not 1, it's 100, which means that this 5 wholes is actually going to end up in the hundreds place, right? So I'm going to have to swing it over. So I'm going to get a 5 in the hundreds place. This 0 to swing over. I get a 0 in the tens place. And I get a 2 in the ones place, meaning that 5 and 200s times 100 actually gets 502. So that's one way to look at this. The other way that we just talked about is that I could look at the pattern. I'm going to erase this stuff. And I could say, oh, okay, there's a pattern. Oh, okay, there's a pattern. Apparently, that's what I say. And if we look at that pattern, we see that this is 1. I'm multiplying by 1, 2 place values greater, right? 100 has 2 more place values than 1, which means that this decimal is going to jump 1, 2 place values, which would end up with 502. And we end up with the same thing. So that's what we kind of get into. This is confusing stuff. So I'm not going to sit here and pretend that after listening to me babble for 20 minutes, you get this completely. And if you do, great. That's awesome. My babble was wonderful. It worked today. But if it didn't, that's not on you. That's the complexity of this math. So ask your questions. When you get into your practice buddy, ask questions. I know I say, well, when you choose to be independent, you're being independent, but it's okay to raise your hand. It's okay to come down to the carpet, bring your work and say, hey, I'm working on this, but I'm a little confused, and get that help. Okay. I'm going to zip it up. Super long video in this case. I appreciate your patience and thank you for trying on this new thing, and we'll see you next time.